Lunar Math. The process started out with me looking up information online as you do and found a formula that must be a reliable one. It takes the forces of gravity of the masses of both the moon and the earth. I'm multiplying them together, taking the gravitational constant, which is the force of the objects obtained from the friction of subatomic particles, g, then dividing them by the total radius between the two objects, r, while multiplying it by itself, squared. Metric units were all used to make the process easier to convert in the use of kilon units. And the gravitational constant 6.67 e to the 10th power negative 11th, 5.972 e to the 24th times 7.348 e to the 22nd divided by 3090 760 squared, and you multiply them all together to get 1.9168 e to the 26th. Then, getting creative is necessary to isolate the value of time. The formula with that which I use when you are trying to disprove the mainstream of the fact of not being very factual. It requires you to use the total force of the first problem, the TF, how much the moon drifts away each year from the Earth, that is variable, not fixed, d, to its tidal forces, and then you divide it by the velocity of the moon in relationship to Earth, v, and divide it by the hours in a year. Then you take the whole number, square root it, for two gravitational bodies would get closer, these objects would accelerate faster. So the hours should be divided beneath the square root because you're taking the velocity to the hours to get how much it's drifting away each hour. Then take the total number of hours in a year, which is 24 hours in a day, to get relative force of the orbit. And I take the total force times the distance of the moon divided by the velocity square root, get 4,440 million 712,503 divided by 24 times the 365.25 hours and days in a year, and get 50,736. Now the values are way lower than the estimate given by mainstream science, saying it's 4.5 billion years, yet there's one more step you must take. You must take the numbers that and divide them by the value of pi, or 22 divided by 7. Because of the fact we're dealing with a circular orbit, but since it's not perfect circular orbit, I used 2.9 for a certain reason, which is about 20 divided by 7. Those numbers are bottom range of which, while the top are the divergent numbers obtained from the previous model. You take the last number, which is p, divided by 3.14 squared, or 2.99 squared. You do that and you get either 5,173 or 6,064. With this, you got the data range of Earth being either those years old when it was last in lunar contact to the Earth. Now, the reason I have the sets of data is because one implicates in the Bible 6 is the number of man, while the longer one works out as well. The number is more reasonable to how old the Earth is. Like I said, all these numbers seem to meet the criteria that disproves the fact that Earth is a lot younger than what is stated by mainstream science, and is by a few billion years to boot.